Okay, this is example 4 in section 5.1. What we're going to be doing in this one is solving equations using nth root knowledge right here. So what we're going to do is first we're going to look at a, which is 4x to the 5th power equals 128. Now, when you are solving a problem, that means you're solving for x. And just like any equation we've done all year long or you've ever done in algebra, when you're solving an equation or solving for x, that means you have to isolate x and get a value for that variable. So what we're going to do is when we look at our problem, we want to start going through all the operations that we need to do to get x by itself. Now, the first thing we have to do right here is divide both sides by 4. Okay, we want to get x by itself. So when we divide by 4, we get x to the 5th equals 32. Now, what we have to do on this is we want to go ahead and get rid of this exponent here. Now, what we can do to do this is we know, because we know about rational exponents, if we can take this expression to the inverse power, that's going to get rid of our exponent. So what we want to do is we want to take this term to the exponent that's going to get rid of 5. Now, we know that anything to the first power is just that value. So if we can take our expression to the inverse power than what we have right here, that's going to eliminate this. So for example, if we have x to the 5th power right here, and we take it to the 1/5, so we're just taking it to 1 over, that's going to become x to the 5 divided by 5 power, which is equal to x to the first power. That's just going to equal, sorry for the writing, that's going to equal x. So what we want to do is go through these steps because that's going to get our variable isolated. Now, when we do that, we can't just do that operation to one side. We have to do the same operation to the other side. So if we do 32 to the 1/5 power, that's going to reduce this value to our answer. So what we do is we go ahead and take each side to the 1/5 power. Now I've just showed you right here how taking x to the 5th to the 1/5 power will isolate x. Now all we have to do is just calculate what 32 to the 5th root will be. Now you know that 2 to the 5th power gives you 32, so when we calculate this out, we get x equals 2. Now that gives us that our solution is x equals 2. If we went ahead and plugged that in here, we'd get 2 to the 5th is 32 times 4 equals 128. So when we check our work, we go ahead and prove that this is the right answer. So your steps here are just working out your equation to the point where you've got your variable isolated to whatever exponent is in there, and then you just perform your inverse exponent to both sides to isolate your variable and get the solution. Now, that's what you do when x is just by itself. X is your base to an exponent. Now, that's not always going to be the case. You see right here that your variable is inside parentheses. And also, you're not always going to have a nice clean base here. You're not always going to have a number that is evenly taken by a root or works out to a nice clean solution. So here we've got x minus 3 to the 4th power equals 21. We have to go ahead and do our inverse operations to get our variable by itself. Now, in this one, we can't just add 3. That's a common mistake. Okay, x minus 3 is a term that's connected together. So a lot of people would make this mistake right now that you would add 3 and then take that to the 1/4. Please be sure that you don't do that. X minus 3 is together. So the first thing we have to do is take both sides to the 1/4 power. Again, I showed you last time, if we take this to the 1/4 power, that's going to get rid of our exponent. And what that means is that we also have to take 21 to the 1/4 power. Now when we do that to both sides, we're going to end up with x minus 3. Remember, that was in exponents right here. So we took our entire expression to the 1/4 power, and we ended up with 21 to the 1/4 power. Now you have to remember, when we are taking an even root, we always have to account for the positive and negative of each case. When you have an odd root, you know that your answer is either positive or negative. When you have an even root, you're going to have two potential answers, the positive and negative. Okay, so now what you do is you go through and you isolate x. So here, just like in some quadratic equations, you're going to have two potential answers. Now to isolate x, we have to go ahead and add 3 to both sides. And we're going to get a solution right here, which is 3 plus or minus the 4th root of 21. Okay, now the way you can write this, you'll have two answers, 3 plus the 4th root of 21 and 3 minus the 4th root of 21. Now this is not a clean root. 21 does not have a nice even 4th root. So if you plug this into a calculator, you get two potential answers to this. We round it off to 2 digits. You have x equals 5.14 or x equals 0.86. If you plug this back into a calculator, these are your two solutions, and you would get that both of these satisfy this equation. Okay, so the key things right here are making sure that your order of operations are in the correct order and that you're always isolating x. Make sure that whatever exponent x has, you always take your both sides to the opposite. Now, the same holds true if you had something like the 5th root of 20. So the 5th root of 20x, equals 5. To get rid of this, you would take both sides to the 5th power to get rid of this. Because remember, the 5th root of 20x is just 20x to the 1/5 power. Okay? And that's just to the 1/5. And to get rid of that, you would just take both sides to the 5th power. So right here, that's what it would look like. Okay? Now, remember, your exponent is not always going to be a integer. Sometimes you're going to have it as a fraction, and when you do the opposite, it's just going to be taking that to whatever is going to undo that and make it as an exponent to the 1st power. So that looks a little different. I just wanted to show you what another example of these exponents would be. So what I want you to do right now in your journal is I want you to do problems on page 127, problems 16, and then 18, 19, and 20. So you can skip 17. So 16, 18, 19, and 20. And thank you very much. That's some good journal work right here. I'll go ahead and tell you, I'm going to have the teacher tell you what your homework is going to be.